Hey, welcome to this my live stream. For example, last no, this is not the last day. I think we still have one more day yet to come. No, I'm totally lying. Actually, this is the last. No, this is the last day, but it's not the live stream. We still have Chrome Dynamine event plus an introduction to Python thanks to Ridby coming up. Then tomorrow we have the closing ceremony for wrapping up this amazing global hack with data. As always, I like to introduce myself. My name is Alberto. This is my stream for displaying your data with Matplotlib, which is a Python library. So might not be an introduction, but we will learn some basic things about how to set up properly your environments in Python, and well, how to display your data. Please, before I forgot, because I always forgot to mention, help me joining, registering for this event in mlh.io/events 1134.2. And well, let me know what time is it for you, because for me it's pretty late. It's almost midnight, and well, that may be the reason for not a lot of hackers be joining, because well, it's pretty late. But for some others, it's pretty early in the morning. Um, so let me know here in the comments what time is it for you, and if you can hear me and you can see me, right? Because I don't know, maybe you are not hearing me, right? I would like to have a little help in that. But if don't worry, I can start. And tell me how it's been your global hack week this far. Have you learned some new stuff? For me, I've learned a lot of stuff, and I've been having a great time doing these streams. My first one was about how to connect MATLAB with Python. Then using JavaScript plus Mongo, we create some apps. We store our data, and this last, it's specifically for how to display that data, creating graphs, creating these scatters, plot, bars, um, what else, 3D graphics, meshes, a lot of things. And you will love this session. So let me start sharing my screen. Okay, it's here. So I think you can see it now. I hope you can see it now. And we will open a new tab in the browser. I normally use Firefox. And we will look for Matplotlib. And well, it opened me exactly the page I wanted, but let's think you don't. So Matplotlib, and is this one, matplotlib.org, visualization with Python. And I don't get these symbols, but well, it's for this. Also, you will see that a common search when you look for matplotlib, it's numpy, pandas, scipy, and even scikit-learn. NumPy, it's a very, very good friend for almost all Python libraries for that scientist, but we are not focusing on NumPy this time. But I want you to know that we are going to use NumPy. Matplotlib, it's how, well, put it this way. NumPy, it's how you generate the data, you process it, you transform it, you make mathematical stuff. And Matplotlib, it's now when we have that, how we display it in a sense that normal people can understand it, can appreciate it, can see it, really see it. So let's go to the Matplotlib page and you will see this is a very simple explanation, a visualization library with Python. We can try this online, but we are going to download it, so don't worry. The page has the getting started guides, some examples. We are going to actually take all these examples and explain what they do and how we can manipulate them. And well, here's the, the page so you can download it. The reference, cheat sheet, and the documentation. Before we start, I want to know how many of you have experience with Python. Um, I don't know if you knew this, but Python works with virtual environments. You can manage these virtual environments just installing Python, and that will be good. Then you will have some things for projects for installing these dependencies. You will have the package manager for Python. It's pip, um, but that can get very hard sometimes. And I use helper for this that's called Conda. The full environment, I think it's called Anaconda, which is open source distribution for managing these packages and well your environments and a lot of things. All the good packages, the trusted ones by the community, are here on Conda. Well, almost all. Um, but it is not necessary for you to have the all managed system uh, Conda. I only use a small version of that it's called Mini Conda that I don't think we can find here, but I'll get one step. It's just the package manager version. Again, it's open source. For example, here's the one I was talking about, the Mini Conda. Mini Conda, it's a free minimal installer for Conda. It's a small bootstrap version of the whole Anaconda environment. I think Anaconda comes with a graphic, GUI to manage these packages and well do a lot of stuff in an application. With Miniconda, you have to do it all on terminal, but I like it better because it's lightweight. So it's Miniconda, right? Conda install for you. They have a configuration here. Does it mean Conda is paid? No. Where you get that? Oh, they have a pro. Yeah, you're right. I didn't even know they had a pro version of this. I don't know what this includes. Pro tier, world's more popular open source package distribution, open source, leverage, key features, more than building data science, machine learning packages, access to the commercial package repository, ability to leverage minor software to create copies. Well, didn't know this exists to be honest. But well, for me, the free trial, it's all I need. Huh? The topics. I think when you want to do stuff online, like for example these Anaconda notebooks, or have them borrow a computer in the cloud to run all your heavy stuff, the pro or the business or the starter, the enterprise, those won't make sense. But we are going to do this all offline with the Miniconda. So don't worry, you don't need to pay for anything. And well, here's the Miniconda. Sorry, the Conda. I thought I opened it. The comparison Miniconda or Conda. Oh, maybe the link it's wrong. Well, we can find it on Google, I think. Mini or Anaconda. Should I use Miniconda or Anaconda? Create and publish by Anaconda votes yes. Has Conda votes yes. Has Navigator. This one does because it's a graphic way. This one doesn't. This one, the number of packages, it's between codes because I used just Conda for the environment managing, but then you can install all the packages in pip. So I don't know. I think that it doesn't make sense. But see, this is a great difference. The install space the required to install the whole Anaconda distribution, it's up to 4.5 gigabytes. This one it's less than half gigabyte. Uh, so yes, wiper for Conda if you can do it in pip. Yeah, I don't know to be honest. Uh, I hope someone from Conda team could explain, but my recommendation is don't pay. I think you can do it just with pip, and I only used it as a helper for the environments to get not for the packages, and I will show you in a minute what I mean with that. Um, for example, this is a great difference. I always say this. Anaconda, it's great if you don't have that much experience because, again, having to manage all these environments, packages, and a lot of things you need to do to work with Python can be difficult. So the GUI helps you to create these environments and manage them in an application, and you can see it in a visual way. If you are not too confident working with the terminal, Anaconda will be a better um option, but the price you have to pay for that, it's a lot of space in your disk, to be honest. um, if node, same as Sherhinks says, you can do it all by Python instead. Uh, hey, for the Novida, I missed that before. And well, this was the question. Does it mean the Conda is paid? Actually, they have a paid version, but we don't need it. Thank you for the question. Didn't realize that before. So then returning here, installing Conda, we can install Mini Conda and just download the one better for you if you're Windows or Mac user. If you're Mac, you want to do it Bash, PKG for Apple, Silicon, or for Intel. Linux, but if you do Linux, you probably know this better than me, but here's how you can install. Um, and that's it. That's all we need. This Conda and the Matplotlib documentation here. And now let me show you what I mean with these environments. I had prepared, well, I can do it here. I can do Conda list to check how many environments do I have. No, sorry, this is the packages. Conda, what's the command for this? I forgot. Uh, env, I think env list. Yeah. So I have three environments. The base one I use, actually, I use this specifically for school. The Matplotlib that I created, sorry, Matplotlib just that I created for this session. And for example, this Python MATLAB that I created for the previous session I have on Monday. Oh, I forgot I can do this. I had on Monday that, well, why I create new environments for this and that, because I use different versions of Python, for example, for this base, that for this one. These two can do the same actually, but it's a good practice to separate your packages, your environments, your versions, these kind of things. And if you want to do it per project, you can create an environments folder, and you can do it with the just Python. You don't need conda. But again, I want you to have this alternative because I do think it's easier. The most easier one it's Anaconda full version. Then the mid level could be just mini Conda. Both has Conda, and the most complex thing it's just do it vanilla, just Python. And now we have set this up. We can move to this. I created this folder. Go ahead with data matplotlib. Then another thing you have to do to activate this, it's conda activate. For example, in this case, if I want to use the Matplotlib environment, or conda deactivate to quit it. And you can see I configure my terminal to show me in which Python environment I am, and if I have something turned on and turned off. You can do this via your what's the well, I use CTSH, so you can do it via your bash profile file. And I have these, which are the examples we are going to take a look. These, as you can see, are Jupyter Notebooks files. And if you don't know what a Jupyter Notebook is, it's a small, how to say it, it's different than just plain text because in a Jupyter Notebook, you can have sections of code plus text. This text will be in Markdown. For example, this one, I can modify this, but I can run separate pieces of code. I can add more sections for the code, for the Markdown, for blah, blah, blah. I can run a specific part of the file. In this case, for example, it doesn't make that much of sense, not for the sections, for running independent sections. Let me show you an example where this does more sense. I have this folder, for example, which is code develop on for electronic. This is for one of my control classes. I do separate practice folders, and for example, here, first I want to declare and do all the imports. Then I want to define this function, but not call it. And for example, here I define all the functions. Then I just run one of these in separate pieces of code, so that doesn't affect the values of the variables in these other pieces of code. So here it just throws me the output, and this is the other reason why we are using a Jupyter notebook, because otherwise this will be shown on the terminal or the output, or for example in a figure in case of the graphs generated by Matplotlib. But I want it to be part of the script. I want this. I want to show it just after the response of the function I call. So in this case, this value is this represented just before the code. Same as this. This value is this one. So that's the main reason that why we are using Jupyter. If you were not familiar with Jupyter Notebooks, I recommend you to use them. They are a really cool tool. There are other options. There are Google Colab and those kind of things, but it's up to preferences. So we can close this and we can close this. And again, this is not the case. In this case, this is just one section of code. We don't want to do multiple sections, but it makes sense because the most basic example is this one. For example, I can run. It requires you to select the environment. In this case, Matplotlib, it's perfect. Now, it's connecting to the environment. The environment has all the libraries and all the stuff this needs to work, and the output of this is the graph represented here. Let me show you an example of how this will be. Test.py. If I take the same piece of code and execute it in a simple Py script, this is just plain scripts. And for this, I do need to conda activate the Matplotlib. Let me check this exists, the test.py, and Python test.py. And it throw me an figure, it's an output, but I will have to grab it from the other desktop that I have and put it here so you can see it. And it's a separate window, a separate figure. And so here you can compare. I mean, it's the same, yes, I know, but having to drag these every time I run the command, and just having the outputs here on terminal, it's not that, how to say it, it's not that great developer experience. So this is why in this scenario, Jupyter notebooks are better. Another thing I have to say is that Jupyter notebooks are not for production environments. I mean, I cannot make a IPYNB file and put it to run endpoints for a backend, for example. This is just for academic purposes, for investigation, for showing these outputs in a very, very beautiful way. So let's close this. And I already started with the plot one. So we can see the matplotlib.axis.axis.plot function, that it's the one we are using. The BLT, it's how we do the shortcut for matplotlib.pyplot. I don't know what that happened. Okay. And again, I told you we were going to use NumPy. So NumPy as MP, we generate the data first in this step. We say mp.linespace will create an array that starts on 0, ends in 10, and has 100 values. For example, if we reduce this to 10, then instead of a very fluid scene wave, we will just have how to say, a um, triangular function, because in every of these values, this will be 1, 1, 1, 1, 1 directly without the curve. So let's run this. For example, I can run this all, or I can just copy this and, for example, create another piece of code, return this to 100, and say the figure, no, sorry, the new x, let's say new x will be land space with that 10 value, y will be same, yeah, exactly. And well, I think the rest is still the same except of this. This also needs to be new x, y line width, and yep, that's it. Yes, we can run this separate piece of code, and you can see how it affected, how it changed the values. But just one value, that will be nothing. But we can make this bigger to 100 and 100 1000 values to make this fluid. See, actually the range, it's not good because this doesn't get to the maximum value here, but this will be repeated until 100. uh, and for you to see how this can affect different values in different pieces of the code. This is for the comment on Jupyter notebooks. Let's modify, for example, here. Here the value of y, it's plus 2 times the sin of 2 times x. In this case, this will be directly 10 times new x. The new x will have the same values as the other one, but these, let's run all. You see how it increased. So instead of this will be 5. Okay, it moved. This will be again 4 times 2, and this will be 10 times the new value of x. So it's it's more compact, you know. Let's keep this more values between lines, so now we can see it better. And the figures, let's separate this in a new piece of code. Oh, no. Our next code. Yeah, cities. But let's run all again. And this is taking the values of x and y here. But let's pretend we didn't call this new x. It's just x and x. Let's delete all of this. And if I run first this section of code, and then I run the plot, this will remain the same. But if I run this section of code and I run this take the values here. Um, so that's why another advantage of the Jupyter notebooks, because we can take the same variables and call them in different ways. So I used it very often, to be honest. Again, in the example I show you, actually this doesn't go. Uh, in the example I show you before for my control classes, I love that thing. For my control classes, I declared same variables with different values in different blocks, representing different uh, sets of the system. So I call the big block at the bottom, then I go up there and change and run the specific system of the specific set of the values for the system that I want, without having to change them manually or commenting them or doing another tricky things. And that will store the values I want here the operation that I am doing. So, for example, I can call this example one, or this is uh, example. This is the one, and actually, this is the two. No, And what I like to do it's also to separate this import. You saw how I like to do the inputs first, because if you keep running the inputs, I think it's time that well, here it says 0 seconds, right? But many cases you have very big libraries that you want to use, and you don't want to be importing them all the time in your scripts. You just want it to be load on memory and then run all the piece of code that you want. So take the example one, don't run the example two, and do the operation. And I have this output. Then don't run example one, take the example two, and do this operation. And the value changed. This is how I use um, Jupyter notebooks for doing this type of analysis. So again, I know there are many ways to do this in simple Python files, but I don't know. I think this is a very clean, uh, graphical way to do this. You still have the values. You have documentation on what those values represent. For example, let's not call example one and example two. Let's call example in case where the how to say it, the sine wave is not high frequency. And instead of example 2, example in case the sine wave it's high frequency. And that's exactly what it is. And also, for example, if you take this and pass, create a function that's, sorry, a lot of JavaScript in my head, def plot sign that has these x and y values. Actually, it's the same. But store this and then have this function called plot sign and pass x and y values as you have. Same here. And you run them all. Oh well, I need to grab this piece and put it in the top. Oh, sorry, this one, the one I needed to put on the top. And you have separate outputs for this. You know, even I changed the order. The comment here tells where this is the not high frequency, and according to the image, that's correct, and where this is the high frequency sine wave, and that's correct too here. And I just declared function one time, and well, this is the normal use case for a Jupyter notebook, right? So continuing with the Matplotlib topic, let's go to their web page and see the getting started guide, because here on the getting started guide, not only they have a draw first example, we do this in a very similar way, but they have these plot types, and this is where, for example, you can download the the file I was just showing you with the plot types for Jupyter.zip that will download you this exact folder that I have here. And let's go to see uh, all of this. We already covered this one, the plot one. Uh, you can see another example here. So let's see the scatter one. If I go to the scatter plot, you will see the function for calling this. It's ax.scatterplot. The subplots come from PLT. So first of all, let's go to see what that is. So let's open the references. Oh, plot types, user guide, reference, app reference, Matplotlib, dot pyplot here. It's a state-based interface to Matplotlib. It provides an implicit MATLAB-like way of plotting. So, recalling for the session of Monday, Matplotlib, Python and MATLAB are more friends than we thought they were, right? It is open figures in your screen and acts like these figures are UI manager. So what does that mean? We don't necessarily need to call this with pipeline. We can do, well, we can perform actions over the figures, but I want to show you an example of how what difference it's with just matplotlib without pipeline. So let me look for the plot patch projection service case table ticket. I am pile lab. No. Uh, example. Let's see. Uh, no, I don't want a basic bar. This, for example. No, it has a pipelet. Module pipelet. Open lines bar. Module. Term style sheets. This is very nice. Okay, I'm done. Let's use just pipelet without worrying about too much shit. So returning here, let's run the scatter plot, selecting the Matplotlib environment I created. Let me take some water while this loads. Hmm. I misread. This is the stack plot. I wanted to check the scatter plot. Sorry. Okay. For the graphic, we can understand these are points in a two-dimensional space. But what does that represent in data? Different from the plot, for example, plot just join points along a simple axis. Uh, in this case, our requirement is that not two points are repeated on a same space on X, but here is different. Here we can repeat these type of values. So let's see how this data is generated. NumPy generates random from the seed tree, and it gives us a normal distribution of data from 0 to 24, if I'm not wrong. I can't remember here if it was from 0 to 2. Uh, let's ask a pilot. Three arguments. The first one, it's the mean center of the distribution. It's the standard deviation. And 24, it's the generation of round numbers. Okay, so let's generate more data. 50. And let's run. You see how now the dots increased. And every time I run this will be different. No, it didn't change. Let's quit the seed. So every time, yeah, every time it's different. The seed was the same. That's why the random generation was not random. But without seed, this random generation takes the time, well, the exact moment I run this function at the exact moment doesn't repeat in history of life. So that's why every second it's infinity, and we have to appreciate every moment. But forget it. If we could recall the exact moment in time and set it as a seed, we could repeat moments. For example, hit this four, it's always be not random. It's always be the seed of four. Um, but okay, it's more fun every time we run this, it's the same values. The sizes are again random, but in this case, it is not a normal distribution, it's a uniform distribution. Again, we can call Copilot to explain this. In this case, the arguments represent low, high, and size. In the lower boundary, okay, so I get it. The lower sides it's 15, and the higher sides it's 80. Um, the length in the number of random values to generate here. Okay, and the sizes, length length of x. So it depends on how many of these. Okay, colors scatter. Let's see why the colors are that way. Hi, Mumuliki. What did you mean with S theta? S comma theta. Oh, sometimes I look at the picture I'm presenting here and think that that's my window, but no, it's funny. Do you mean S comma theta? No, I don't get this comment. Sorry. Like me, would you like to explain more? Okay. Returning here. The normal, no, the uniform distribution, the lower value, the higher value, and the number of random values to generate. Um, so we'll generate a number. So in this case, for the normal distribution, comes to 0 to 2 sizes. 4 plus minus 2, it would be 2. Okay. Sizes. And the scatter gives the x and y values, nothing much to say there, in an array of sequence of numbers that specify the size of each point in case of the scatter plot, and the color of the sequence of colors that specify the color of each marking in the scatter plot to the data. Okay, Capella is good, but sometimes we need to check really the documentation here. So let's open the reference plot types, user guide, colors, specifying colors. It's an RGB. If that's value, we add blue. Hmm. The transparency, subplots, demo default, style. So we can change styles. I know that. So here using MP gallery. But what I want to do is to see why colors has passed the uniform distribution string. I think that doesn't make sense because this is RGB, this is case sensitive, case insensitive RGB, but they are all starting with a string. And in this case, this is not a string, this is an array of values. That's why I'm intrigued. But maybe this is something specific for this scatter plot. No, it's just scatter. Here, scatter plot. Here, all the values are random, and they have different colors. Here we have a value set from 15 to 80. And why does that mean? That's blue. They use the following instruction: axis scatter or pipelet scatter. Oh yeah, this is the example I was looking for. Amazing. Axis, axis. The axis class represents the one subplot in a figure. It contains the plotted data, axis stick, blah blah blah. Okay, so scatter demo, scattered with legend. Let's see this scatter demo. Oh, let's return a little bit to see just one thing. Same with pipeline axis scatter. Example using it's supposed to using axis that scatter. Price data, price data. delta, volume close figure at scatter delta. Okay, but where it's the color that I wanted. CBook load number record of any of your Yahoo CSVs. Cookbook get sample of this. The price get the most recent of the 200 days. Difference of the price, mark the price. Okay, price data. This PLT it's plot. The axis that scatter for delta minus one, delta one, close, close. Don't get it. It's supposed to be closer from delta or closer from what? Between these. So let's try it with our example with a specific number. Comment this. And let's say that now colors will be mp dot array of times length the x of 1. All are white. Let's let's do something gradual. And this will be dot 55 255, sorry, and this will be mp dot lin space that goes from 0 to length to 1 and 2x, and run this all darker blue but same blue RGB. That's weird. Yeah, it doesn't make sense to me, but okay, we will take it. Hmm. Okay, let's try. It's to ask Copilot. Copilot. This is from 80 times length here. All will be same color. This type of blue. Let's increase this to more than 200. Let's say 300. Run. Let's say 255. I think this will be the same. Yeah, no bigger than this value. Even if I do 500, yeah, done same. Why in a scale of blues? That's why I don't get completely here. Um, Hoped to see this on the documentation, like a detailed explanation on colors, but here shapes and collections color doesn't tell me too much for a description of the color maps available, but this is color maps, like know for what I want. Color by y value. scale data, scatter gives y as scale c. C it's right like or list of colors or color optional. The maker colors possible values as a scalar sequence of n numbers to be mapped to colors using CMap and norm, a two-dimensional array in which the rows are RGBA. For example, I want 250 0. What will be this? Zero. Red, just red. No, this is an error. What I am doing wrong. Let's print colors to see what I am doing. This is not a two-dimensional array. That's why. Uh, one here, one Y, one here, and this goes here. Run all. Okay, yeah, this is a two-dimensional array. No, RGBI value should begin with. Oh, this is from 0 to 1. So 1, run all. Okay, yeah, now I get it. That makes more sense. But I didn't understand why the scalar sequence mapped the colors to blue. A single color format string. Note that C should not be a single numeric RGB or your RGBA sequence because that is indistinguishable from an array of to the color mapped. If you want to specify the same RGB or RGB value for all points, you set two-dimensional array with a single row. Okay. Otherwise, the value timing will depend and blah blah blah. Defaults to none. In that case, the color might terminate about the color, the face color. In those that's not identified. Okay, nice. But let's put more speed in this because we need to cover more plot types in this part. We've just seen two, which is great because we see what we can do, how we can do it, how we can manage this, how to change color, how to organize them, how and in which cases we data represent what. But let's keep exploring. So this far we've seen the scatter and the plot. Let's see now these ones. That's the bar. And bar is one of the most easy ones. I think, for example, here when we want to display the different values of, let's say, here, and we arrange an x goes from zero point 0.5 to a range of x. In this case, we're going to change this from 0 to an range of 10 values. Let's run this again. What did I do? Oh, we did more values here. Yeah, two more values, right? 5 and 4. Run off. Okay, now I understand what they do here with this zero point 0.5 to fix this to match everything. That's perfect. And the MPR range will be there from 1 to 11. X lim from 0 to 11. Uh, no, to 10. So first value has 4.8, 5.5, 3.5. In this case, let's do instead of 4.0, 1.0, and 1.3. Remember the normal distributions, and when in statistics teacher told you to organize values so now they can represent the Gauss belt? Well, let's do that. Oh, we need to change what we are showing, right? Um, let's create another graph, which is var ax dot var set ax dot var x normal with white, let's color white, line with no color. This will be, well, let's do that. Don't worry. It changed, you see, but no, I want this to do different. Yeah, that looks different now, but still I don't see this as a normal distribution. Yeah, this is random. Compiler, you fail me. MP, is that correct? No. Take y array and sort it to be normal distributed. Oh, I think it's just sort. But it delete the rest. Uh, I don't think this will work either for what I want, but it's a good example too. Okay, they are sorted, yes, and this should change when I change values. Okay, but you see, data it's here, but now it's sorted. If I want to sort it the other way, hmm, okay, we will don't get too picky with this. I just wanted to show what the bar graph is, how you could do it. Oh, I see some comments here. Maybe Compilot is in feed on breaking change. Um, Does docstring work here? What do you mean with docstring? I don't get you. Hold shift plus tab out of function. Huh. Hold shift tab shift tab. I'm using Mac. I don't know if you meaning shift tab or command tab or option tab or what you want me to do with this command docstring. Maybe we can ask here in the chat directly because what I'm thinking about your comment is that you're mentioning that compiled it's not getting the context of the file. Jupyter has docstring. Uh, Maybe I don't know what that is. It will show you what sort can do. Oh, I get you. This is the docstring, right? Or or I'm getting you wrong. No. um, let's look for it because I don't know if I know what is Jupyter docstring. Tab complete to show docstring. Oh, okay. I think you can type its name followed by a question. mp.sort this. Okay, but I need to run this cell. Okay, after running cell, docstring will display it in the output area below. It's supposed to be displayed now, but it don't. Oh, here it is. Signature. Ah, okay. Wow, didn't know this existed. Can you Google and see image um, here? uh, okay, didn't help that much, but now I get it. You're meaning this, right? Yeah, that's it. Amazing. The whole thing just was funny. Say Jupyter notebooks. That's really cool. Didn't know this existed. Thank you for showing me this. So A access minus one can no called signature the arguments A array like int or known optional axis along which to sort. If you known the array will be flattened before sorting, default it's minus one. So if I want to change this, I'm supposed the axis will be one. No, ha, zero. Okay, still don't know what this axis is. Quick sort, merge sort, the kind of blah blah blah. The order string of the string list implementation. That's cool. Okay. Uh, I'm not using it this moment, but that was really cool to know this existed. Trick, ha, yes, thank you so much. So let's continue. Continuing with our functions here, the var and the steam are almost the same thing. I mean, for in terms of functional, they work the same. That they are like the same, uh, almost the same thing. The difference, it's well, if you want to have a more clean way to represent this and stuff. Plus the stairways, it works the same. Actually, if you delete the lines in between and don't fill the bars, you will have the stairways, right? So uh, many of these are very similar. For example, these scatter plot, stack plot, sorry, the stairs, the steam, the bar. I think these four are very similar on how they behave. Visually, they are different, of course. For example, if you have a discrete system, you probably will be using this bar, stem, or stairs. But if you have a continuous system with multiple values, you probably will be using the stack plot, right? What else? This works perfect, for example, when you want to display the values, and each value in X has a specific value in Y. But same as here in the bar example, when you want to display the different values in X, I think var it's better than steam or stairs, because otherwise seeing in palm values here on stem can be not funny to the eyes. Um, so on the stem, let's run this, and the output is this one. Let's return to our bar value and copy this data, so you can see it's very similar. Actually, let's copy the whole the whole function here, and we are going to add it here. Make blah blah blah. We are commenting this. We are commenting this. Figure, it's the same, so we are commenting this. AI stem on X and Y, and the set of the limits, we are commenting that. This one too, and just moving these to the tops. And instead of the bar, we are going to join this. Then we can run, and you can see. Actually, let me add an alpha. Well, color by default it's fine. You can see, I told you, it's almost the same in essence. If you don't feel the whole bar, you just want a specific point. Plus, we can delete this line, so just point here. It depends on what you want to display and what you want to tell with this data, the stories you tell, and how you move your, well, not move, how you do these tricks, how you manage to say, for example, in comparison with this and that. We can see here, yeah, the storytelling, it could be a great way to say this. And now let's add this to the stairs, because they will be almost the same. Yep. Except that in the stairs we don't need x value, but let me delete this, delete this, and delete all of this, and just add this. No, sorry, the stairs will keep this and delete the rest of this. And for these stairs, I want to increment that by one in every value. So let's run all of this. Mm, Not int. Okay, without the stairs. Stairs plus one, and these stairs plus one will be nope, not append, but let's multiply this y plus one uh, for each value. I don't know if this works in in Python. Can only concatenate list, not integer. I don't want to concatenate. What I want to do is sum one to each value, value each element in y and return a new list. Cool. That's what I wanted. Yes. Why I did this? Just for fun. I mean, to separate this uh, in a graphic way, we can add another thing that's y less one. We can add this one less one to the stem. Use line collection true. We can run this. No. What? Yeah, use line collection. It's not defined. And you can see I give each values different steps here, but all represent almost the same how they change the visualization. Again, it's up to you. I see there are some comments here, so let me check them. How can I see the schedule of the events in that week? How can I see the schedule of all the events in that week? How can I see? How can I see? Okay, I think that's a lot of questions. Let me look for it because if I remember well, there's a specific link where you can check it. But give me a second and I will share it with you. Mm, just give me a second. It's wrong. Oh yeah, here it is. It's ghw.mlh.io/schedule. So here's how. Oh, you with me, Shahings? You're always one step ahead of me. Thank you so much for sharing it. Well, I hope that solves the question. Let's continue to these other ones. Again, the other one we're missing it's this tag plot. We already ran the example of this because, well, um, another thing here, it's not all arrays be necessary the same values. We can give different sets of values. For example, we can make this shorter with a midpoint value of 7, so that will be a big here. What all the input dimension except for the concatenation axis must be exactly. Uh, no, then I cannot do this. This it's what I wanted to do. Sorry. So the big peak is here. Um, and well, you can show separate this place. And the other one fill between run with the Matplotlib kernel. Man, how's those one even get into this? What do you mean? Like how you get into data analysis? I would say the most difficult part of this it's not programming. Yes, I will say the most difficult part is the mathematical behind all of this, because yeah, exactly, because you need to learn the statistics. This is coming from a non-color thought. That's fine. Actually, again, I repeat, the difficulty of this it's not a coding. Uh, Example like this you can find in internet all week long. You can ask Copilot, you can ask ChatGPT, you can ask this AI that helps you generate. The difficult part it's know what to do with the data, what you want to do, how to manipulate it, what does if for example if you apply a normal distribution with that that's the thing we were talking. What does that mean? What you want to do? You want to conglomerate your data, you want to expand it, you want to make them um, discrete, you want to make it continuous. If you have continuous data and you want to compare it with a discrete system, how you discrete your continuous data, that kind of topics, how do you manipulate your arrays to be, I guess this the last example, if you want to do that, sorry, if you want to do that to be same size, do you know what values to quit? Because let's say one is bigger than other, you have to add values to the first one or remove values for the second one. That's a big question. It depends what you want to do. And well, I think today you must learn Python to advance your data science skills. Yes, that's true. But again, the thing here, the key word here is to advance your data science skills. Advance, not to start. The fundamental is the mathematical part. If you want, you learn how to do it in your own hand. If you learn how to do it using other programs that don't require you to program, that can expect your input as just numbers, let's say decimals, let's say mathematical, let's say all those things, um, that's a complicated part. If you want to take it to the next level and increase um, your ability as a data scientist using programming, that's the way. And Python, it's the common the standard for that, at least in the industry. We were talking for example, on Monday about MATLAB, that it's a very, very good language to and helps you to perform. For example, this thing I just did in the previous example of multiplying an array for a scalar and just like that expecting to receive each value multiply of the vector for the scalar. That MATLAB does that without any problem. For Python, you have to be more specific and perform another type of operation. In both, you can do. How you can do it, it depends on the language. Manual work, ChatGPT can do it, and those jobs are no longer available now. No, um, s- I think I don't understand that. What you mean, like manual work, ChatGPT can do it, and those jobs are no longer available now. Okay, I think it's a comment on what I was saying, but yes, the complicated thing again here are mathematics, and not to say oh they are so complicated. Don't worry about trying to learn it because you will you won't. No, no, that's not the comment. The thing it's you have to practice and practice a lot and watch a lot of videos, read a lot of books, but also write functions, well, solve equations, manipulate data on your own. Hand in programming. Again, programming is just a tool for what you want to do. What you want to do is process your data, manipulate it, tell stories with your data. Um, in other cases, even gather that data, right? You have to get it from somewhere. Uh, but yeah, statistics, mathematics, it's the base part, the most fundamental part here. And unfortunately, for example, if you think of boot camps and those kind of things for programming, those are great for technical stuff. I think I even was in a boot camp. Um, it's true that they most of the time they don't achieve their goal, like you will become from zero to expert in 6 months or something like that. But the truth is, for this mathematical stuff, you don't learn that in most boot camps. I even was in one about that science specifically, and I don't know, I have mixed opinions on that, but having the time and the patience to start learning this will get you rewards because no much people can handle all these process of thinking. No much people can do this, and not because it is hard, because it requires compromise from your part and a lot of your time. But again, you will be rewarded for that. If you survive linear algebra, you can bet all. uh, that's funny. If you survive linear algebra, you can bet all. But yeah, put your hands on mathematical stuff, and well, programming will be super easy in comparison of that. And that's the focus of this session, not the mathematical part, but once you have your data, how you can display it, how you can find these tools for make your work as these data analyst easier to what's they have very funny names, data analyst, data engineer, data something else. uh, when you want to show it to your client, to your bosses, to someone that doesn't speak the beautiful language of the mathematics, something, you need these graphics because these graphics can talk for the numbers. And you probably don't know what, or well, you yes, but your clients want to know what this is, what these numbers represent. But if you, for example, in this stack, you say, look at this peak, this peak represents increases. Look at this value represents no sales or something like that. That's the great advantage of these kind of tools. So let's continue because we are about to end our stream. We take a look to the pairwise data, to these amazing things. We still have the statistical distributions. Um, I will skip this because I want to show the grid data examples and the 3D volumetric data examples because they are so beautiful. I really love them. Um, no, the array board sculpture to see color mesh. I think that's one. Yeah, but this was not the one I want. Contour, contour. This one. So imagine, and not only because this looks like a cartograph map, but imagine you have different height values of a surface and you want to display them here. Again, I repeat this example from the session on Monday, but imagine you want to do a linear gradient decrease analysis. Here, in a visual way, I can say we have valleys here on 0 minus 2, on 0 0 more or less, and on 0 2. In a graphic way, you can comprovate that and even do animations to say like, hey, if we record the heights from these and go to the valleys, well, this is two-dimensional. I don't know if these are valleys or peaks, but for the color, I can intuit that this is the valley and these two are peaks. Um, that we can display this, no? And that led us to the three-dimensional, but because the surface one now shows you all the dimensions of this. So scatter 3D will do very fine. No, this surface, yeah, it was this one. I got a sample from not an arrange, but let's construct this as scene waves. X, it's np dot scene of what the steel receives. Yeah, why not? Of X. And G is an MP scene of this. It's not defined, X not defined. Oh, this it's X in uppercase. And this is Y in uppercase. And this will be XX, common YY. And this mesh grid will be constructed via XX and common YY. And the square root of this will be y x x run out. This mesh grid x x is not defined. Oh no, this was only x and this was only y. Sorry about that. And same, I think this was just x and this was just y. Yes, flat surface. This changed. Let me see how the values are here. Print X and print Y, run all. Hmm. Don't know why this, but I have an example of this around in the other code. No, code developer global Hagwig data global Hagwig Matlab. And what we had in the script, it's it's the same, isn't it? Arrange an initial value, a final value, the separation, the mesh grid of this. Oh no, I get it. It's the definition of CETA what we need to change to arrange. Um, Plus, don't know why what R is for, so we are deleting this. Oh yeah, the radius of the value of thing it has here. No, yeah, I understand this function now. Sorry. So we don't need this. We don't need this anymore. And instead of the thing of R, it's of XX of X, just like that, and of Y, just like that. Theta must be two-dimensional. It was, isn't it? Oh, it's plus, not times. Again. Wow. Then it looks like we do need to compare something. Oh yeah, I get it. This I need to change this. Delete all of this. Yeah, sorry, the mess I made at the beginning. Now it's charging me. Wait, what? How could I get schedules for all events? Here it's the link. Uh, Shaheen's make the favor to change to share this. And again, not working. Don't know why. No, this needs to be XX and YY. Instead, that will be wrong. Plot surface of the resulting here, of the resulting there. I could change this to no default values. PLT figure, subplots, projection, the range, and the mesh grid of these values. NP scene, NP scene. Oh yeah, I see the difference now. And this YY. And now this supposed to do. Yeah, perfect. So again, you can see here because there are sinusoidal waves, the peaks, the values, and we can interpret that in a more graphical way if you are not that familiar with how this should look. With the time you start to visualize, for example, you see a function and you say, I know that function should look like this. If you see a square, you know this type of functions go like this. If it's if it is how to say it, an odd number, you'll say it's the number of uh, changes. It's the number of the expression, and it's hard if one goes up and then one goes down and things like that. You start to do this graphical interpretation, but in your mind, but it doesn't harm you to verify that with the software, right? Um, Auto generating same text hitting DDRS lol. Yes. Um, and well, that's all I wanted to show you. I think that's the B box, the plot wireframe. I love that too. Wireframe 3D simple. What? And same, but in wires instead of a mesh. Um, so yeah, this well, I don't see a reason to share this on a repo because again, you can check the folder here. You can download it from this page of the Matplotlib plot types examples. We just make some changes, but for educational reasons, actually, it doesn't affect on how this works. And well, again, no reason to share a repo of this. So let me know if you have any comments. It's been a pleasure to be here showing you how you can access these tools, what you need to configure your Python setups, the trips I learned, the flow, on how I do this. Well, if you have any questions, but you can think it right now, I'll be around Discord, so let me know on the Discord channel. Plus, you can always reach me on my social media. I'm like Alberto47 in all of them. Send me a DM. Send me. I don't use X or Twitter, but you can find me in Instagram or LinkedIn or well preference like that or Discord. So thank you a lot for joining me. We still have two streams coming for Global Hack Week. As our friend Shashi Kumar 765 asked, you can always find the schedule for the upcoming events here on ghw.mlh.io/schedule. And well, see you around, people. Thank you a lot for joining me, and I will see you for the next Global Hack Week. Bye bye.